4, 3, 2, 1. All right, day 23. We have a grid. We're gonna place stuff on the grid. What is the question here? How many empty tiles? I see. Tiles have a starting location. Oh, this is like a Solio automata. Okay. After 10 rounds. Sure. Okay. So what are the rules? R +1, C -1. South one step. Let's see. And this is basically just +1. I see. Two. Empty. What is it? Discard, remove. Like none of these moved. Am I crazy? Oh. What am I doing? Oh. Eating is hard. No L's are in the 8 positions. North is up. Why did they evolve like that? Shouldn't this guy go up? Said he goes east? Oh. God damn it. Northeast, southwest. Well, the lesson is read the problem, I guess. Okay, other people also cannot read the problem. First round where no elf moved is 20. Hopefully it is small. Okay, cool. That went reasonably well. What am I doing? Okay, so what is going on in this problem? You really need to follow the rules carefully. It's sort of a cellular automata, by which I mean something like Conway's Game of Life. So we have these cells, right? So we have a 2D grid, and we have these cells that are on, and then we have this complicated rule set for like evolving the 2D grid. Let's see. I should say, sorry, I'm going to modify this first to like print out the answer to part 1. Probably if I run it with PyPy, it'll be faster. 3788 and 921, and that runs in 2 seconds. Okay, that's acceptable. Right, so we have this 2D grid, and it, every turn, it like evolves in some way, in some complicated rule set. And like basically each point can move up, right, down, or left, or not. And so in part 1, it's just like run this game for 10 turns, and then figure out how big like the bounding box is, and count how many empty cells are in that bounding box. And then in part 2, we need to keep running the game until they all stop moving. Okay, so what are the actual rules for moving? They are tricky. Well, yeah, so they're right here. So if you don't have a neighbor, then you don't move. That's this. And then there's this tricky thing, which I did not handle in a good way, but I don't know, whatever. I guess it's fine. So otherwise, if you do have at least one neighbor, then you try walking in some. So you try walking north, east, south, and west. And if there's no one, anywhere in the 3 squares to your north, then you try going north. If there's no one in the 3 squares to your east, then you try going east. If there's no one in the 3 squares to your south, you try going south. If there's no one in the 3 squares to your west, you try going west. And then you rotate like what order you try things. So in the first round, you try going north. In the second round, what? Surely in the second round, you try going east. I think this is just an error. You definitely try going east first in the second round. In the third round, you try going south. In the fourth round, you try going west. Yeah, so initially you go northeast. Maybe like there was an indexing error. Anyway, you go northeast, southwest, and then the next round you go east, southwest, north, and so on. I did not read this initially, so it took me a while to figure that out. This is, well, I don't know. This is a very ugly way of implementing it, but the actual rotation is simple enough. And then, okay, so that figures out, now you figured out where all the elves want to move. Then there's still a little bit more complexity because now you need to keep track of how many, which elves want to move to a square. If multiple elves want to move to a square, none of them move. If one elf wants to move to a square, then that elf gets to move. So what I've done is keep track of, let's see, this is of elves who want to move to RC. Right, so for each square, I'm keeping track of all the elves that want to move to that square. And if there's more than one elf, then nothing happens. And if there's exactly one elf, then that square gets moved to. And the elf is no longer in its original square, and it is now in the new square. I also flipped this. That was another bug I had. So that is it. Those are all of the rules. And then in part 2, you just print out the first round, one indexed where no one moves. And in part 1, you get the bounding box of all of the elves. So, min row, max row, min column, max column, and then for all the squares, if there's no elf there, +1. And print out the number of empty squares in that bounding box. Yeah, so it's relatively straightforward, I guess. I mean, the hard part is implementing the movement rules. It's small enough to brute force. In my example, the answer for part 2 was 1,000. I guess maybe in principle it could have been very large. Then I would have had to do something else. And yeah, as I did in some previous days, I used a set to keep track of the elves. I think that worked well. I had this function to print out the elves in this format roughly, although that was actually not helpful. Instead of debugging, I need to remember that whenever I want to debug, I should actually go back and read the problem statement first. This is probably not the best way to do this, but whatever. So yeah, pretty much just a question of reading the rules correctly and then implementing them. That's all for today. See you tomorrow.